Hello everybody, this is Jehangir and I am going to present my manuscript innovation on an innovative and novel thermal hybrid indoor solar cooking system that is Solcr cook, which on the basis of optical principles involved means solar concentrating and redirecting cooker. Now let's start with a brief about solar cookers. Solar cooker is an attempt made to create the environment-friendly, effective and cheap cooking system that uses solar energy to heat, cook, or pasteurize foods and other drinks. Although solar cookers are widely spreading in different countries, but there is an emerging market in tropical countries since there is an abundant solar energy while shortage of other sources of energy for cooking. On this slide, some of the common solar cookers are presented for your information, like solar box cooker, parabolic cooker, and in the middle, an example of indoor solar cooker. In 2014, Harmon and others classified the solar cookers into direct and indirect solar cookers. If we see direct solar cookers consist of all those cookers where both solar collector and cooking chamber act as a single unit. While in indirect solar cookers, the system is made of two parts. One part collects and converts the solar energy into thermal energy, while other part consists of a cooking chamber. Direct ones, for example, box type solar cookers, are simple and cheaper than indirect ones, while indirect ones, for example, flat plate solar cooker or vacuum tube solar cooker, are more user friendly. Although there are a number of solar cookers available in the market, but all face some major problems and challenges like indoor solar cookers that work on heat transmission mechanism are too costly and can't be used for kitchen designs built at deep core of the buildings. In all indoor solar cookers, cooking part, cooking part of the system is placed not far from the solar collecting system. If there are non-sunny days or prolonged non-sunny hours, one need to use other sources of energy and technique to cook or warm foods. To address all the issues present in the existing solar cookers, we present here the all-in-one solution in the form of novel, creative, and innovative design of the solar cooker called as Solcr Cook. In the system, by using a parabolic optical concentrator mounted on the top of the building, solar light is concentrated and focused to a reflecting element, which directs the created light beam to the core of the innovative thermal hybrid cooker, that is ITIC, with the help of some optical elements. Inside ITIC, solar beam gets scattered and gets reserved in the form of latent heat energy using erythritol as a phase-changing medium for late-night cooking purposes. ITIC is also inbuilt with electrical heating element that can be used as thermal backup for non-sunny days or prolonged non-sunny hours. This is the first solar cooker where the black body radiation principle is used to harvest solar energy for cooking purposes. Unlike other solar cookers, our system basically consists of three parts. First one is the solar concentration and transmission system, referred in short as SCADS. The image on the screen is schematic layout. It consists of parabolic reflector used for concentration purposes and the secondary reflector that directs the solar beam to the other parts of the system, that is transportation and redirecting system. To neglect the shadow effect, it is attached with the solar tracking system as well. The second part is the transportation and redirecting system, that is TR. On the screen, this part has been highlighted in the enclosed red lines. It consists of a duct pipe, 0.3 Fresnel lens, and 0.2 plane mirrors for a single-story buildings. This part transmits the solar energy from the concentrator to the core of the cooking chamber and makes the system unique and novel to transmit the solar energy to the inner core regions of the building with the help of the sophisticated optical elements used in its construction. On contrary to other indoor solar cookers that use heat transportation mechanism of fluids in our system, this part directly transmits the solar energy to the core of the cooking chamber, that is our RTSC, and thus reduce the installation costs of the solar cooker, meanwhile making the cooker more user-friendly than the available systems. TR possesses also the potential to be modified and get used for other green and sustainable purposes like daylighting inside the buildings or increase the length of the solar line. The third part is the cooking part, and we call it ITHC, that is Innovative Thermally Hybrid Cooker. This is the most innovative, novel, and creative part of the system. The schematic layout can be seen on the screen, where vertically laid two images represent its cross-sectional view and front view, while the third one represents the exact location of ITHC in the system. RTSC consists of two open cooking spots and one closed cooking chamber for different cooking purposes. Based on the optical efficiencies of the optical elements used in the construction of the system, it has been calculated that the end-to-end efficiency of our Solcr cook reaches 83.2%. That is quite enough to make the system efficient for its work. Using the percentage of efficiency and the solar radiant energy data collected by Indian Meteorological Department of Government of India, we have calculated the amount of global and diffuse solar radiation that gets transmitted to the core of our cooker, that is RTSC. The figures on the screen shows the results of Jaipur city, Rajasthan. That is, we have calculated on monthly and hourly basis for the months of May, June, and December. The calculated results paves the way for the exergy analysis and further research and development of the system. Finally, we can summarize the conclusion of the manuscript as we came up with the design of an innovative thermally hybrid indoor solar cooker that can be utilized for all cooking purposes at any instant of day and night, and possess the installation potential to be used at any location of the building. On the basis of factors like efficient percentile of end-to-end efficiency, solar tracking system that neglects the shadow effect, black body radiation approach used in the innovative design of RTSC, and directed transmission of solar energy in place of using thermal transmission approach commonly used in indoor solar cookers. Our Solcr cook can be theoretically considered as the most user-friendly, sustainable, and operationally more convenient thermally hybrid indoor solar cooker than the available cookers. Thanks for your patience.